Hello Savers. So today we're going to start chapter 5, which is on linear equations. So today is section 5.1, which is on rate of change and slope. So materials you're going to want: notes, a pen or a pencil, and you're also going to want a calculator today. So this video is going to focus on being able to find a rate of change from tables and also finding slope of a line using graphs and ordered pairs. You have probably done this before many times, so this should be a review lesson for you. So the rate of change shows the change between two quantities. You can find the rate of change by doing either one of these. So either the change in the dependent variable over the change in the independent variable, or in easier terms, the change in the y values over the change in the x values. More than likely, this one right here is the one you're going to want to get down. That one is probably going to be easier for you to remember too. So let's take an example, look at an example like this. So the table shows the distance a band marches over time. What is the rate of change and what does it represent? So I'm going to find the change in my y's over the change in my x. So the change of y here looks like I'm adding 260. Each time I do that, I'm going to add 260. Looks like I'm adding another 260. Over here, my x values, it looks like I'm adding a 1 each time. So I was supposed to do change of y over change of x. So change of y is 260, and my change of x is 1. So I have 260. So what does it represent? Now, 260, or the change in your y's, that's your distance, right? So distance over time. So it looks like the band can run or travel 260 feet per minute. Now, I'm going to have you guys watch this video. It's kind of corny, but bear with me on it, okay?
Welcome to the Adventures of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him and he'll teach us some important aspects of slope. This is the course he's skiing today. What he says will teach us about slope. Always remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain, but now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski route, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. As he finishes the flat part, he doesn't see well ahead, and all of a sudden he comes to the edge of a cliff. It's straight down. He finds a slope that is straight down, and so frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the adventure of Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said puff, puff, positive. On his downhill run, he said nice, negative. On the long flat part of the course, he said this is zero fun. And finally, when he went over the vertical cliff and straight down, he yelled the worst curse word of math and algebra. Undefined. The uphill is a slope with a positive number, the downhill is a slope with a negative number, the flat part is a slope of 0, and the straight up and down or vertical part is undefined. This has been the Adventures of Slope Dude. Special thanks to Kim Yui for...
Alright, so we're going to take a look at the path of Slope Dude. Now, the reason why I showed you that is I found that this really helps to remember the different versions of slope. When he was on the uphill, he was saying puff, puff, positive. So when I'm going uphill like this, it is a positive slope. So when he was going downhill, if you remember, he said nice, negative. So this is a negative slope. Now, when he was going like this, it was straight, it was hard. He said this was zero fun. So this is a zero slope. And then he screamed the worst curse word in math, undefined. So that's an undefined slope going downwards. So I found that a lot of people have, this helps you kind of remember what each of those look like, especially zero and undefined. A lot of people get those confused. So what kind of slope are these? So it looks like I'm going downhill. So Slope Dude said nice, negative. So this is a negative slope. This is uphill. So he said puff, puff, positive. Now, this is a flat part, so remember, that is zero fun, so it's zero slope. And then straight up and down, that was the curse word of algebra, undefined. So now, what you're asking is, well, Miss Marsh, what if they give me a graph, but I need to actually find the slope? So what you're going to want to do is you're going to want to rise and then run. So you want to start the leftmost point and you're going to rise, go up or down to the rightmost point. Then you're going to run over to it. A lot of people call this rise over run. This is an actual pretty accepted formula for slope. So let's find the slope here. So we're going to do rise over run. So I'm going to find a point. Looks like I got one right there and right here. So I'm going to rise and then run. So I'm going to go up until I get to the same height as that point. So I'm going to go 1 and then 2. So I went up 2. Now I got to run. I got to run. Oops. Looks like I'm going to run to the right 1. So I'm going to rise and then run. So rise over run. 2 over 1, which is the same as 2. So my slope of my line is 2. Now let's look over here. If you notice, I have no actual little dots on here. So I'm going to make some dots. It looks like I go straight through 2. Right there. It looks like I'm going straight through 3. So I'm going to want to go up until I get to 3. So I'm going to go up 1, 1, 2, 3. So I went up 3. Now I'm going to run over 1, 1, 2. I'm going to run 2. So rise over 1, it's going to give me 3 over 2, which can't simplify. Now, make sure you leave slope as fractions and not decimals. That's for a later section. But now, another question. What if they don't even give us a graph? So we need to be able to use the formula that I have there. y2 minus y1 all over x2 minus x1. So you're going to want to figure out who's your first point and who's your second point. So here I have 2 points. I have negative 3, 3 and negative 5, 4. So I need to figure out, I'm going to say this guy's number 1. He's number 1 point. This guy is my second point. So off to the side here, I'm going to write x1, y1, and x2, y2. Now, x1 is the x value of the first point, which I know is negative 3. Now, my y1 is the y value of my first point, which is 3. x2 is the x of my second point, which is negative 5. And y2 is the y value of my second point, which is 4. So now I have all the values. I need to just put it in the formula. So y2 was 4, so I'm going to do 4 minus y1. y1 was 3, so I'm going to go 4 minus 3. All over, or divided by, x2, it looks like I said that's a negative 5. Subtract x1, which is negative 3. So I'm going to do subtract a negative 3. So 4 minus 3 is 1. Now, negative 5 minus a negative 3. When I have double negatives like that, remember, you're going to get positive. So I'm going to get a negative 2 out of that. So I'm going to have a negative 1/2 for a slope. Let's try one more, and this is the last slide of the day. So negative 1, 3, and 2, negative 1. So just like I said, we're going to say who's x1, who's y1, stuff like that. So I'm going to say x1, y1, x2, y2. So my first point is this guy. I'm just going to say that's my first point. Now, if you wanted to go for second point here and first point there, you would still get the same answer as me. Just make sure you know who you are putting as your first point. So my x in my first point is negative 1, y1 is 3, x2, 2, and my y on my second point is negative 1. So now I'm going to subtract my y's from one another. So I'm going to do y2 minus y1. So negative 1 minus 3 all over x2 minus x1. So x2 was 2 minus a negative 1. Negative 1 minus 3 is a negative 4. And it looks like I'm going to get 2 plus 1, 3. So I should have negative 4/3, which cannot be simplified down. Hope you enjoyed the video. See you later, savers.